Okay, 8.4 is on vectors and dot products. So we're going to learn about dot products of two vectors, use the properties of dot products. We're also going to find the angle between two vectors and determine if they're orthogonal, which just means perpendicular. Okay, we'll do the vector sum of two vector components, which we've been doing. So the dot product, what it is it's kind of like multiplication of two vectors, but obviously vectors are not numbers, so you can't just multiply them like you would numbers. So what you have to do is you have to multiply the x coordinates together and add that with the multiplication of the y coordinates together. So let me show you an example. So we could do this one for part A. We'd do 4 times 2, which is 8, plus 5 times 3, which is 15, and that gives us the answer for the dot product, which is 23. Okay, the next one, 2 times 1 gives you 2, plus negative 1 times 2 gives you negative 2, which the dot product would then give you 0. Between these last two vectors, 0 times 4 is 0, plus 3 times 2 is negative 6, so when you add them together you get negative 6. That's the dot product. Now, the dot product between two vectors has some properties, kind of like multiplication has properties, and a lot of them are similar. For example, the commutative property of multiplication follows with vectors as well, where order doesn't matter. If you multiply by 0, it's still the same. You still get 0. This was what we called the associative property, or I'm sorry, the distributive property still holds true. You multiply a vector times the sum of two other vectors. And you know, we still have, if you do the dot product between two vectors, it's going to be the magnitude squared. So I guess this one's a little bit different. And then, you know, you can multiply a scalar through, and that's kind of like what we call the associative property, only where this is a number and the other two are vectors. Okay, next is the angle between two vectors. I put this formula on our formula sheet, and we're going to use this quite a bit in the web work homework. It says the cosine of the angle between two vectors equals the dot product between the two vectors divided by the magnitudes of the two vectors multiplied together. So let's try an example problem of that real quick. Let's find the angle between these two vectors. The cosine of theta equals the dot product between the two vectors divided by the magnitudes multiplied together. So that would be the cosine of theta equals, the dot product would be 4 times 3, which is 12, plus 3 times 5, which is 15. That gives us 27 in the numerator, divided by the magnitudes multiplied together. Now the magnitude of this vector is the Pythagorean theorem, so it's going to be 4 squared plus 3 squared square rooted. So this is going to be 5. And then this magnitude is once again the Pythagorean theorem, so it's 3 squared plus 25 plus 5 squared square rooted, which is square root of 34. And now we can just do the inverse cosine. So let's do the inverse cosine in our calculator of 27 over 5 square root of 34. Now I'm going to put my calculator in degree mode and give this answer in degrees. So in the calculator we would do inverse cosine of, and I'm going to do alpha window here so I don't make a mistake with any of the parentheses or anything. So it'd be 27 in the numerator, and in the bottom I have 5 square root 34. And I think my calculator's in radian mode. So let me close this parenthesis and then go to mode and change this to degree. I'll give the answer in degrees here, because we know what we're going to get an angle for our answer. That's what inverse trig functions give us. Hit enter and we get 22.17 degrees approximately. All right, the last thing then is just orthogonal. Orthogonal just means perpendicular. So if you think about it, the cosine of theta equals the dot product between u and v over the magnitude of u times the magnitude of v. Well, if the dot product's 0, then what you have is the cosine of theta equals 0. Well, where on the unit circle does the cosine equal 0? Well, that happens at 90 degrees right here. So basically what that is our theta would be 90 degrees. Or obviously, you know, negative 90 degrees, you know, but either way, that's perpendicular. So this orthogonal, if u times u dot v equals 0, should make sense. That if the dot product gives you 0, then you know, in this formula for the angle between two vectors, that means that the vectors are 90 degree increments apart from one another, which is perpendicular. So orthogonal just means